All right, I think we'll get started. It looks like it's 12 o'clock. Um, Welcome. I'm Matt Helmers with Iowa State University and ISU Extension and Outreach, and the director of the Iowa Nutrient Research Center, and faculty affiliate with the Iowa Learning Farms. And I want to wish everybody a happy July 4th and hope you all have a great long holiday. Certainly send out our thoughts to those in Northwest Iowa that have had a very challenging week with the flooding and so forth, and thinking about those. That's certainly on the minds of many here at Iowa State, and thinking about how we can be responsive to that. Today, we are really fortunate to have Dr. Shelby Gruss. Dr. Gruss is an assistant professor in Forage Extension at Iowa State University. Many of our clients were excited, can speak from my own experience when I recently made sure everybody knew that we had a new forage extension specialist, and they were excited in Northwest Iowa thinking about that. So it's been a little while since somebody's been in that position. So we're at Iowa State University excited for Dr. Gruss. And so you didn't log on to hear me talk. So I'm going to turn it over to Dr. Gruss and to talk about exploring traits and tactics with summer annual forage. As always, if you have questions or comments, feel free to type those into the chat box. We'll get those to you at the end of the talk. With that, Shelby, the virtual floor is all yours.
All right, thanks for having me today. I'm very excited to be here. And so, like Dr. Helmer said, we're going to be exploring traits and tactics with summer annual forages. And so kind of like to start off with why we really think about summer annual forages. And so these are just common forages that we have throughout the state, throughout the US, and their general growth rates throughout the year. And so a lot of our cool season perennials that are in the black box, we really see them do well in the spring and then as they go in the fall, but they don't do well during the summertime. Our winter annuals, our small greens, some ryegrass, they start to fill in the edges a bit more. So they go up more further into the fall and start earlier in the spring. But we still have that missing summer gap with that high heat. And so we have our warm seasons that start to fill that. We have our warm season perennials. A lot of times people aren't as interested in these because they take a really long time to establish. But once they're established, they can be really great forage opportunities. But then we have our summer annuals. I really like our summer annuals because they can fill a quick niche. They can grow really quickly. A lot of times we could be getting forage within 30 to 45 days, depending on the conditions. And so in situations where we have lost a lot of our forage, or we just need a quick opportunity from prevented planting, a flood, taking out some of maybe our corn silage, some other things, these forages can fill a gap in those situations. And so they're really great in those opportunities. Additionally, they're generally really good. They're really drought tolerant. And so on the top graph, we have 3 different summer annual species. We have teff, sorghum, Sudan grass, and pearl millet. And so this is the overall biomass they were able to produce in the summer. But overall, what's interesting is how much biomass they're able to produce per inch of water they receive. So on the far right, what we have is the crop water productivity. So every inch of water that these plants received, they were able to produce about 485 pounds to 696 pounds of biomass. And so that's a pretty substantial amount of biomass for a limited amount of water. And so this is comparing itself to another C4 crop or warm season annual. And so what I have down here is basically a little different. We have sorghum, Sudan grass, and pearl millet as our summer annuals, and then tall fescue as our cool season. And I would say tall fescue is actually a pretty drought tolerant crop as is. And so what this is, it's basically how efficient the plant uses water. And so the higher the number, the better. And what we can see here is that sorghum, Sudan grass, and that pearl millet can really utilize water a lot more efficiently than some of our drought tolerant cool seasons. And so summer annuals can really fill that gap with that high heat of the summer when generally our water starts to slow down and we don't have as consistent rainfall during that time. And so with that, we have a lot of summer annual choices that we can be looking at. There's forage sorghum, our sorghum Sudan grasses, Sudan grass, pearl millet. There's a slew of millets that could be chosen. There's just two on here, pearl millet and foxtail millet, that are listed. Tests. All of these are really great options that we could be thinking about when we're thinking about what kind of summer annual forage we could use. For the sake of this presentation today, I'm really going to be focusing on forage sorghum and sorghum Sudan grass, just from some work that I was doing in my previous position, and how those can work in. And then I'm going to get back into what I'm trying to work on here at Iowa State, and that's going to bring in more of the other forages as well, or summer annuals as well. Why I am such a big component of our sorghum forages is, again, they do really well and they're drought tolerant. They can perform well in low nitrogen environments. They thrive in that semi-arid and arid to arid environments. I kind of think of them as more of emergency crops. Crops like something went wrong, let's get some kind of forage really quickly. They can produce a large amount of biomass, and there's a lot of variation in these in sorghum forages. I mean, just looking at this photo here, you can see we have something that's almost 20 feet tall, producing a large amount of biomass, compared to something that's a little bit smaller, maybe producing more green focused, etc. So you have this variation that could fit different needs. And then we do have, it is a high nutritional value crop, especially when containing the brown midrib trait, that really helps increase that nutritive value. But a lot of times people kind of shy away from our sorghum forages because it produces a cyanogenic glucoside called dhurin. And so when we're thinking about that, it can be problematic. And so somehow my slides got a little bit mixed up, so we're going to backtrack just a second. But these are just some traits that you can see in our different sorghum forages. We have the brown midrib trait, like I just mentioned, that can really increase that nutritive value. Photoperiod sensitivity, that's allowing more biomass to be put on, because it's more on day length, so normally they don't head out in our environment. We have some other ones such as brachytic dwarfs. We're increasing the leaf to stem ratio, trying to get more leaf material to stem, because our leaves are generally higher quality. Male sterile lines, those are getting pushed kind of hard right now. Basically what those do is they don't produce seed. So the panicle will emerge, the pollen is sterile, so unless external pollen comes and pollinates that plant, it won't produce any seed. And so the idea behind it is the sorghum seed is actually not super digestible, so we're keeping the nutrients in the leaves. And so we don't have a sink for the nutrients to get pushed to the seed. And so it accumulates in the stems and the leaves, increasing water-soluble carbohydrates that are actually being shown to be stable during silage production. So there's a lot of interest with that for increasing quality, and then there's a lot of disease-resistant traits out there. And this last trait is kind of a near-future trait. It's prussic acid-free sorghum, and that's bringing us back to what I just said about that cyanogenic glucoside. And so when we're thinking about prussic acid or dhurin, so dhurin accumulates high levels in the leaves and the stems. It depends on the growing condition in cultivars. Different cultivars can have high levels versus lower levels. Same with species. So a lot of times we see this with our forage sorghum having high levels compared to, say, a Sudan grass, which is lower levels. But why do we care about dhurin necessarily? Dhurin accumulation is what contributes to hydrogen cyanide or prussic acid poisoning of livestock. So hydrogen cyanide and prussic acid are the same thing, but that's that poisoning that can kill livestock. And so dhurin's broken down in a pretty simple pathway. When animals come and chew on the plants, they chew on them, they cause the cells to break down, and you get this release of hydrogen cyanide or prussic acid, which is very dangerous to our animals. And so typically we manage for this. That's what how we control for it. So we don't graze plants that are too short. We don't graze plants that have been frosted, like directly after the frost. And we avoid some plants that are really under extreme drought situations. Those are some of the management strategies, or we're using it in a way that helps release that hydrogen cyanide before animals eat it, such as silage, green chop, and those type of opportunities. But what if we could just kind of get rid of it? What if there's a way to make dhurrin-free sorghum? And so what you see here on the right is basically the pathway of how dhurrin's created in the plant. And so it goes from tyrosine through 3 enzymes, and then we get dhurrin. And so from previous work, we realized that we could mutagenize, basically eliminate this enzyme. And without that enzyme, what we got was no dhurrin. Without dhurrin, we don't have prussic acid release. And so this mutation was incorporated into sorghum lines. And what this looks like is basically this photo here. So what we have here on the left is plant tissue from the leaf. The leaf material always generally has the highest amount of dhurrin accumulation or prussic acid potential. And you freeze it, and then after you freeze it, that basically breaks the cells open and it causes it to release hydrogen cyanide. And so what we see here on the right, this paper is a treated paper that if it interacts with hydrogen cyanide or prussic acid, it causes the paper to turn blue. And so in our dhurrin-free lines, we have no prussic acid release. Since there's no dhurrin, we don't have that prussic acid. And we really wanted to understand how this could be beneficial in our forage settings. And one of those big factors is dhurrin accumulation following a frost. There's been a lot of research that's shown that dhurrin can accumulate after a frost. What recommendations can vary based on this, but generally animals should be removed from the pastures for at least 1 week. And this is a rolling suggestion. So if you have one frost on Tuesday and you have another frost on Thursday, that week restarts on Thursday until the plant's completely killed. And so we wanted to see, okay, we have this dhurrin-free hybrid, but sometimes we don't know exactly if it could revert back somehow. And so we wanted to test this in comparing our conventional and our conventional sorghum lines versus a dhurrin-free line. And so we used fresh tissue from corn as a baseline just to say, like, there's no dhurrin. This analysis we did was super sensitive, so sometimes you get a little bit of a minor error, but we found the dhurrin-free was consistent with our corn control. But what we saw is, so on the tables on the right is we have basically days following a frost. Day 0 is the day before the frost. So it's within 24 hours of the frost. Then we have 3 days later, and then we have 7 days later. And so these were tissue samples taken from living material. And in the dark brown or the dark gray is what we're seeing from our conventional hybrids. And so what we saw from Colby, Kansas is on day 3, we had an increase in dhurrin accumulation. And then 7 days later, we still had a continued increase in dhurrin accumulation. But our experimental hybrid never had a positive dhurrin. So basically, we were able to determine that these were safe. And then in West Lafayette, what we saw was 3 days later, we had that dhurrin accumulation. But then by 7 days later, it had declined again. And why we think there is a difference between our Colby, Kansas location and our West Lafayette, Indiana location is basically the number of frosts received. I would say West Lafayette, Indiana, we had what we considered the perfect frost. We had 1 frost, and then the temperatures rose, and we had a clear week without another frost that occurred. So that plant was able to stabilize again. Where in Colby, Kansas, we had consistent frost occurring over and over again. So we had frost on day 1, and then I think we had another frost on day 3, and then another one on day 5. So basically that plant was continually undergoing that stress. But with that, with the dhurrin-free not having a response, we were able to kind of test this actually by feeding animals. And so plants were monitored consistently using that test where the paper turns blue throughout time. These animals were able to graze. Our first frost, I think, was on October 26th that night, based on the timeline. And these animals were able to graze all the way throughout. I think we had them on there for another week before the forage had run out. And so we were able to show that this actually is a consistently safe option for these plants, for these animals. Next, we wanted to understand how palatable this hybrid is. Like, yes, it's a safe option, it's a great option, but if it's not palatable, animals won't eat it, and then we're going to have some performance problems potentially with this. And so we did this with ewes, and we were trying to look at just preferential grazing. And so in the light blue bars is before grazing. So this would just be our yield of those plants. And then the dark blue bars are basically after they graze. So they graze for a few days, we removed the animals, they were allowed to selectively choose what they wanted to graze, and we then took that final yield, what was left. And so the difference between the bars determines basically how much they were eating. And what we noticed is the Duran-free, you can see, was one of the few that were significantly different from the start to the end of the trial. And we found that the Duran-free was grazed almost 15% more in the cycles, in our cycles 2 and 3. Cycle 1 is not included. We had some wind damage and some rain and some other things that basically we had to throw out cycle 1's data. But we were able to determine that the Duran-free was grazed significantly more compared to our other ones. And what this looked like is, it was what I'm going to show you now. So basically, we flew these fields with the UAV as well, trying to look for differences in green cover. And so in these photos, basically the white is green plant material. Everything else is background noise to soil, maybe even a sheep in the plots, depending. And so on day 0, this is before the sheep were able to enter. And we're going to follow really the red boxes. It starts off fairly consistent across all of our hybrids. Within 24 hours, we were already seeing the Duran-free was grazed consistently higher compared to our others. And then by day 2, 48 hours later, there was not much left in our Duran-free plots. And this is kind of what it looked like. It was mostly just stems at that point. All the leaf material was gone. And the animals were starting to graze other plots at that point. It's like, okay, that's really great. We have a product that's safe, and now the animals do eat it. But most importantly, will animals actually perform on this Duran-free hybrid? And this was a question that we really wanted to answer, because at the end of the day, this is one of the most important factors for forages. It's to feed our livestock, it's to make that happen. And so we compared 2 hybrids, an S&W SB4105, which is a BMR headless, to our Duran-free. We had 24 calves on this allocated to 6 plots. And so we had big plots, and then we had them separated into smaller paddocks so we can rotationally graze them for 60 days. And we tested our nutritional quality on these. We saw consistent nutritional quality between the two, with the Duran-free doing a little better in ADF and NDS, having a lower value, especially when they're in that vegetative growth. And still, even when the Duran-free started to head out, it still maintained a lower NDF compared to our conventional hybrid. But most importantly, we saw that weight gains were very similar between the two. After 62 days, they were within 200ths of a kilogram between each other per day. So they were gaining almost just under 2 pounds per day for both of them. And so with that, we have this product that's there's no prussic acid release. It's safe to graze. It was very palatable and had equivalent performance. Our Duran-free sorghum could be the best management strategy for HCM toxicity concerns in forages. But what other ways can we use products like this and our summer annuals? Is kind of where I really want to continue working with this. And so can we increase resilience in our systems? And so a traditional Iowa forage system is perennial season grasses, cool season grasses. They're one of our opportunities to be able to graze most of the year. They have good production across the wide range of timeframes. And so they work really well in most pasture settings. We have corn silage and alfalfa or alfalfa grass hay that we use as stored feed to be able to support our animals during time of maybe the summer slump when those cool season pastures aren't producing well or overwintering. And so thinking about different ways of incorporation, our common incorporations are generally followed under summer annual, winter annual rotations, sequentially grazing, and then swath grazing is becoming bigger. And so looking at this summer annual, winter annual rotation, how does that work? How can we use that to maximize our basically forage availability across the year. And so you'll have to have two fields for this, because you'll have your field that generally has our cool season forage that will be grazing from basically mid-May into late June, July, and then again we'll be grazing in the fall. And so how can we give these plants a rest when they're not producing well? And so that with summer annual, winter annual rotation kind of comes into play here in field one. We can have our plants are warm season forage late May, early June, and then we can start grazing them almost within 30 days, 30, 45 days. And we can graze them into September, right before kind of our last frost. We can terminate them, and then we could plant that winter annual. Having that winter annual planted, we can graze it earlier in the spring than we normally could be introduced into our cool season pastures. People are also using this rotation for silage production. It's a very common silage producer. You have your summer annual, you basically allow it to grow out, you cut it for silage, and then you plant your winter annual coming around, cut that for silage. So there's opportunities there. The system I was just talking about is how you would work with sequential grazing, how you'd be going from one forage to another when it's producing its best, so that we can give our plants, when they're not producing well, an opportunity to rest, to recover, especially when we're talking about our perennial species. And then swath grazing. Swath grazing is a little bit of a newer tactic that's being talked about, but it's being picked up quite a bit. It has a lot of interest. And so this is when we plant our warm season forage, and we can take a cutting of it during the year and it'll regrow. And we allow it to regrow all the way into the fall. And basically the frost will kill it, making it safe if it's a sorghum species, because of the sternin production. That killing frost will make it safe. And then we swath it right before we start grazing it. And so in the studies that have been done, they've been swathing it in December timeframe, and then they allow their animals to graze it. They're using strip grazing, and they're able to graze their animals for quite a few months in the winter time. And so we're not having that stored feed cost. And so some ideas that I'm working on trying to expand how we can use these summer annuals is looking at maximizing alfalfa establishment. And so throughout the Midwest, a lot of alfalfa acres are getting taken away to put into corn silage. Corn silage is a great opportunity. I don't think there's anything wrong with corn silage or anything. I don't want anybody to think that. But there's been some research going on trying to figure out a way to help with the alfalfa establishment year, because that's a big part of why people don't like planting alfalfa if they're not going to, because you don't really get a crop that year. And so they're basically using corn silage as an alfalfa nurse crop. And so they plant it in 30-inch rows. They plant the alfalfa at the exact same time. The alfalfa is growing between the rows, and this is giving an opportunity to get a corn silage cutting the year of alfalfa establishment. One of the problems with this is some of our alfalfa varieties aren't as shade tolerant necessarily, and so they don't do as well. And so there's been a lot of research going on trying to figure out what alfalfa varieties work best under that corn canopy, because the corn canopy will close in mid-July, and that has been inhibiting some of that alfalfa growth. I'm wondering if this system would work better in a summer annual situation. So in this photo here, we have basically it's a sorghum variety trial for forage. And what happens when we can cut these multiple times. So if our canopy starts closing, let's cut it, get some forage crop off of it, open up the canopy again for the alfalfa establishment. And so we're doing some research on seeing if we can do this for spring planted alfalfa. So that's when the two will be planted together, but then also a late summer planted alfalfa. After we take a cutting of that forage sorghum, let's see if we can intercrop the alfalfa in at that time. And then that way there's less traffic on the alfalfa throughout the summer. So just some different ideas I'm working with. And then another one with these is our cover crop integration. So this was a study or a survey done by the Economic Research Services for the USDA. And basically it just shows how often we use our cover crops for grazing or hayed, basically harvested in some way, versus it's not harvested. And so what we have is basically in the dark blue and the green, these is showing it's grazed or harvested, and the yellow is that combination. So cow-calf people are always almost using their cover crops in some type of forage way. Dairy, same, they're using it at 72% of the time. And then with no livestock, we're still using it about 46% of the time. So how can we use these cover crops as a forage in the best way possible while still maintaining some of the goals we use for cover crops and hopefully not hindering those aspects? And one of the aspects that I'm interested in is the goals versus mixtures versus monocultures. How can we maximize what we're doing? And so in a systematic review, basically they found that 88% of the time, the mixture and the monoculture performed similarly. And they were not just looking at biomass, they were looking at biomass, suppressing weeds, scavenging nitrogen, conserving soil water, stimulating soil biology, and different aspects. And so they're not just looking at biomass. 10% of the time, they're looking at monocultures actually work better than mixtures. And then only 2% of the time, the mixture did better than the monocultures. And so sometimes when I think about this, I think mixtures are a great opportunity because it helps add diversity to our system. But we have to have enough of that crop to produce to get the benefit from the crop. So if we have a full field of cereal rye, it's going to do a really good job of scavenging nitrogen. But if we have only 5 plants of cereal rye and a smaller area, then it might not do as well compared to 100 plants. And so how can we maximize what we're doing, but still maintain mixtures and being able to benefit it? And then one of my things is there's always limited fall growth. We have a limited growth period during the fall. And so generally following after corn, studies found that it only got about 163 pounds per acre. The highest following corn was 964 pounds per acre, so about a half a ton. Soybeans, they saw in this study, on average, it was only 285. There was a field that was able to get about 1.5 tons per acre, but this was like over six years, 7 locations. So it was very limited that they could get a high amount of biomass production. But when you're able to follow something like wheat, when you're able to get it in earlier without the canopy, they were able to get quite a bit more biomass during that time. And so I'm interested in seeing if we can do cover crop integration in some of these warm season annuals, and particularly thinking about the ones that don't produce durin, like the durin-free variety I was just talking about, because we can get a cutting that's going to regrow, but we're opening up the canopy for cover crop growth during that time. So can we interseed cover crops after our cutting, our first cutting or second cutting, and get more growth going into the fall? So maybe we could have fall grazing or even just a hay crop at that point. And when we're thinking about fall grazing, that's why I'm thinking of those durin-free varieties, trying to avoid any concern about prussic acid poisoning at that time. And so this is some of the research that I'm trying to integrate in currently here in Iowa to see how we can maximize that forage production throughout the year. And with that, are there any questions? I think we're going to go through some other slides real quick too.
Yep, we got some question, or we got some additional slides. There's time for questions. I can help with these, Shelby, so you can catch your breath. So if you're on today and would like to or need to earn, a CCA CEU, please send Elena Whitaker, and her email is alenaw@iastate.edu. Send her an email by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. So Elena w@iastate.edu would be one to consider, to send to, sorry. And next slide. If you watch this webinar live and are willing to fill out a voluntary demographic survey, we'd greatly appreciate it. Only one survey response is needed for all 2024 webinars. And you can go to iowalearningfarms.org/web survey. Excuse me, iowalearningfarms.org/survey. My brain is already on vacation for the 4th of July. I greatly apologize. You can also scan the QR code. So again, only one survey response is needed for all 2024 webinars. And for those that have filled it out, we greatly appreciate it. Thank you very much. We'll plug the last slide. Next week, we have Dr. Andrew Margonaut from University of Illinois, Urbana-Champaign. He's going to talk about overlooked non-point and non-ag sources of nutrient losses, the case of stream bank erosion. So Andrew's been doing a lot of work in Illinois on this topic. I think a pretty important topic. So with that, we do have some questions that have come in. Oh, yeah, lastly, if all these webinars are archived, looks like the recording is working, so they're archived. You can go to iowalearningfarms.org/webinars, or we have a YouTube channel as well for the webinars. Okay, now, first question, Dr. Gruss, what do we give up in insect resistance without the Durin?
Yeah, so that's a great question. That is one of the big components of the prussic acid production is insect resistance. So we did do a study with fall armyworms, and so chewing insects would be probably our main concern with that. They did show a bit more susceptibility to insect feeding. In the free choice study, what was interesting is as they were seedlings, they were still able to compete. They just were a bit more susceptible. Now when we're thinking about more aphids and feeding insects that feed directly into the xylem and the phloem of the plant, they actually don't disrupt basically the cells. And so when you don't have that disruption, Durin doesn't release hydrogen cyanide. So I don't see that would be, they would be more susceptible to insect feeding, like sucking insects that don't disrupt cells. But chewing insects, there was a slight susceptibility to those.
Okay. The next one, thoughts on when the Durin-free sorghum will be commercially available?
So they did release it in small amounts this year. They had a couple bad years in their production cycle that had limited some of their seed production, but they're hoping that it'll be more widespread next year.
Okay. And when is forage sorghum maybe a better alternative than corn for making silage?
Yeah, so that's a great question. Corn silage just has that really high starch content. And so it can be, it's just generally preferred if they can grow it well. I see forage sorghum as an opportunity if you're in a tar spot area. It's not something I want people to be replacing all their corn silage with, but more of a savior crop. Like if you have 100 acres, plant 20 of it to sorghum. So if we have an extreme drought, we have tar spot, something that affects corn that sorghum can outgrow, because say sorghum doesn't get tar spot. It's just an opportunity to use something else just in case we have bad weather or bad situations that occur. And so I'm never going to say, let's just switch everything to one thing. Yeah. I'm more trying to say, let's diversify so we have opportunities if something goes wrong. So it's more of a savior crop idea in my eyes, or prevented plant situations. Because if you're talking about we can't plant something till mid-June, forage sorghum, we're still going to have an opportunity to plant and get a crop off of. So things like that, thinking about it in those ways. Or if you want to graze, grazing is a better opportunity there. But
okay. For areas that are flooded out, is it too late to plant sorghum, or would we be better suited with a cover crop mix?
So you could be thinking about planting sorghum till about mid-July. So if we could get if it gets dried out, about July 15th is about the line that I'd say I'd be, if you can't get it in, I'd be a little bit more thinking about a cover crop mix, an oat, or a winter annual type thing that we can just worry about getting it in the spring.
Okay. Okay. I guess any other thoughts that folks might consider with some of the wet conditions we've had this year? Anything with this summer annuals, so forth?
Yeah, so the wet conditions and stuff, if it can get dry and you have some fields that were washed out, things like that, I would definitely be thinking about potential summer annual usage, especially during this time when the water generally shuts off. It doesn't seem like it is currently. Things that I would be looking for, though, if you are thinking about, you had some flooded situations, is assessing that damage to your fields. Alfalfa doesn't really do well in submerged situations, and so assessing your alfalfa fields if your field was submerged, and looking at the sediment and silt deposits that have occurred on the field. Those can be damaging and risk for your animal's health because you're increasing the ash content. And then also microbe populations could be high on those plants at this time. So just those kinds of things as you're thinking about assessing your fields after the waters start to recede.
All right, that's yeah. Oh, okay. Here's one with the forage sorghum. What about the risk of volunteer sorghum the next crop year?
So forage sorghum, it's a little less likely that it'll have some volunteer, especially for cutting it for silage. We don't want that seed to mature. For silage, we're thinking more of the milk stage or earlier. So it's less likely to occur that way just because we're not allowing the seed to mature. Mature sorghum seed is not digestible at all. And then by the next year, even if that plant ratunes or regrows, we're not going to have the frost is going to kill it. We're not going to have it survive winter.
All right. Again, if somebody needs a CCA CEU, please email Elena Whitaker at alenaw@iastate.edu by 5 o'clock today with your name, the name you entered to watch the webinar, and your CCA number. Put in a plug for Andrew for next week, and Andrew Margonaut on stream bank erosion. And Shelby, I hope that we can get you back when you get some of the data on these interesting things with alfalfa and so forth. This looks really exciting, and I think important work as we think about forages and establishment of that alfalfa. So with that, I'll give you the last word if there's any last comments you want to make to attendees.
Just thanks for having me today. If you have any forage related questions, please feel free to reach out. I'm happy to discuss.
Okay. All right, I stopped the recording. Thanks so much, Shelby. That was great. Really, really interesting.